All right, today we're going to do part one of the Float Your Boat Lab, and I have some helpers who are going to help me out with this, and that is my children. So the first part in the Float Your Boat Lab is on page 38, and it looks like this. It should already be glued down from last week. So the first question says, what is density? You can write your own definition of density, but density is the amount of matter or the amount of material in an object. Now, my little kiddos, my monkeys, y'all need to listen to this. So the second question says, what makes something sink in water? What must be true for something to float in water? So if something sinks in water, that means it is more dense than water. And if something floats in water, that means it is less dense than water. Okay? So now we're going to make some predictions about these objects we have. So first, Elise, hold up the marshmallow. Okay, Elise, do you think that marshmallow is more or less dense than water?
Less.
All right, Elise's prediction is less, so I'm gonna write down less. All right, Elise, do you think it will sink or float in the water?
Float.
All right, Elise thinks it's gonna float, so I'm gonna write down float. Okay, Elise, put it in the water. Put it in the water, baby.
Where?
In this bucket right here. What did it do?
Float.
Your prediction was correct, so the actual results float. Okay, who has the penny? All right, Benjamin, do you think the penny is more or less dense than water?
More.
Do you think it's gonna sink or float?
Sink.
All right, so he says more and he says sink. All right, now guys at home who are watching this video, you're making your own predictions. If you agree with my kids, fine, but if you wanna make your own predictions, you can. All right, Benjamin, put it in the bucket. What did it do?
Sink.
All right, so your prediction was correct. The next object is a ping pong ball. Who's got the ping pong ball? All right, Beatty, do you think it's more or less dense than water?
More.
Do you think it's gonna sink or float?
Float.
Okay, now remember things that float are less dense than water. So do you think it's more or less dense than water?
Less.
And do you think it's gonna sink or float?
Float.
All right, so he thinks less and he thinks float. All right, put it in, let's see what happens. What did it do?
Float.
All right. Now, golf ball. Who's got the golf ball? Benjamin, do you think it's more or less dense than water?
More dense.
Do you think it's gonna sink or float?
Sink.
All right, so Benjamin says more, and he says it's gonna sink. Now, Benjamin, very gently, please don't throw the ball, but very gently put it in the water. Let's see what happens. It sinks. Good job. All right, now we have paper clips. There's actually two of you who have paper clips. Yep, Beatty and Elise both have a paper clip. One is a small paper clip and one's a big paper clip. Beatty and Elise, do you think those are more or less dense than water?
Less. Less.
Do you think they're gonna sink or float?
Sink. Sink. Float. Sink.
You think they're gonna sink and you think they're gonna float?
Yeah, float.
And do you think it's more or less dense than water?
Less. Less.
He thinks it's less. You think it's more?
Yeah.
Okay, so hold on a second. We're divided here. So Elise thinks it's more and it's gonna sink, but Beatty thinks it's less and it's gonna float. All right, so drop in your paper clips. Drop them both in.
They float.
They both sank. So who was right? Whose prediction was right? Elise, good job.
Well, those are kind of less because they're not that big.
They're not big, and do they weigh a lot?
No.
They're not very heavy, but they're still less dense than water. They're still more dense than water. So weight and density aren't the same thing. How heavy something is and how dense it is not the same thing.
Are you going to
All right.
clean that up for Benjamin?
Nope, let's just wait a minute. We're not to that yet. Who's got the nail? All right, Elise, do you think that's more or less dense than water?
Less.
Is it going to sink or float?
Sink.
Okay, remember, things that sink are more dense than water.
I mean more.
So you think it's more dense and you think it's going to sink? All right, so Elise says more and she says sink. Let's put it in, see what happens. What did it do?
Sink.
So the iron nail did sink. All right, now we have foil. I want Beatty to go first. Beatty, you have a ball of foil. Do you think that that ball of foil is more dense or less dense than water?
Less.
And do you think it's going to sink or float?
Float.
All right, so Beatty thinks it's less and it's going to float. All right, put it in. Let's see what happens. What did it do?
Float.
All right, it did float. Now, just a second, Benjamin. Now, our next thing, did any of the results of any of the objects surprise you? So were any of these did any of those surprise you, Benjamin? I see you shaking your head. Yes. What surprised you?
That the paperclip sank.
You thought the paperclip was going to float?
Yes.
So why did you think the paperclip was going to float?
Because they're very light and they're easy to carry.
So it didn't weigh a lot and you thought it was going to float. So that surprised you.
Can I
Okay.
move this?
Yes, you can move it. All right. So, okay, that's enough moving. So guys at home, you're going to say if any of the results surprised you and why. Is density the same thing as weight?
No.
Why isn't
Mommy,
it?
I'm going to say my favorite thing. Yes, it is. That surprised me.
All right. What thing surprised you, Beatty?
The golf ball, because I thought it was going to float.
Oh, interesting. All right, Elise, what surprised you?
I thought this was going to sink, not float.
You thought
was going to sink too.
you thought the ball of tinfoil was going to sink too?
Yeah, because it's heavier than this.
Okay, so you've used the word heavy a couple of times. Hands out the water, guys. Now, is density the same thing as weight?
No. Yes. Yes.
No. Density and weight are not the same thing. Let me ask you this. Elise, can you float in water? If you're in a swimming pool, can you float? Can you lay on your back and float? You're pretty heavy, aren't you? Do you think that, let me get this out. Do you think you're heavier than this golf ball? But you float and this golf ball sinks. Okay, so you see weight and density are not the same thing. Do you understand that? They're not the same. Weight is how heavy something is, and density is how much matter is inside that. All right? Now, I'm not done. Chill out. Now, your challenge, guys at home, this is on page 39, where it says, what is the problem? State your problem in your own words. Your problem, your challenge, is going to be to design a boat. Design a boat that carries 30 pennies. And my kiddos here, I'm going to let y'all do the same experiment, okay? So you're going to design a boat that carries 30 pennies. What happens to this penny when we stick it in the water?
Sink.
Okay, so hold on a second. So when I start piling pennies on top of it, like if I started piling pennies on top of this nasty wet marshmallow, what's going to happen to the marshmallow when I pile pennies on top of it? If I piled a bunch of them on there, it would sink, right? So what could we do to our boat to help it carry 30 pennies?
Put something else on it with the 30 pennies.
Okay, I'm glad that you brought that up, Benjamin. So the only materials that you have to make your boat are tinfoil. One sheet of tinfoil that is a size 12 by 12. That's why I gave y'all rulers at home.
Mom.
So what are we going to have to do to our boat to make it be able to hold 30 pennies?
I know.
What?
Make the boat out of the tinfoil and then put 30 pennies on the tinfoil.
Okay, could we use tinfoil like this? Would this hold 30 pennies?
No.
Okay, so what are we going to have to do? We're going to have to, no, No, you may not. You're gonna have to spread your boat out like this, right? Now, go ahead and put that in there, Benjamin. Okay, now if I started piling pennies on there, it's gonna try to sink, right?
Can you put that
What
penny on there?
if I put this golf ball on there?
It would sink right away.
What if I just put water on there?
It would not sink.
It's not gonna sink with water on there? Let's see.
No. No. Not sinking. No.
The water just kind of keeps coming off of it, doesn't it?
Yeah. Try to put the golf ball on it and see if it doesn't sink. It doesn't really sink, but
It's going down.
it's gonna roll off.
All right, so when we design our boat, we're gonna get one piece of tin foil that's a 12 by 12. You need to make it look like a boat. Does this look like a boat right now? What does this look like?
A piece of tinfoil.
It looks like a piece of tin foil. It looks like a raft, right? It looks like a raft, not a boat. So yours needs to look like a boat. It has to be made out of tin foil. It has to be a 12 by 12. It has to hold 30 pennies. It needs to travel the length of about a shoebox. So it needs to be able to travel the length of a shoebox. Your boat has to be able to withstand wind and waves. So when you put a ruler in here and you make waves like this, your boat has to stay afloat, holding the 30 pennies. Okay? So my kids, my monkeys, just a minute Elise, y'all are gonna get to design your boats tomorrow and test them out to see if they hold 30 pennies, if they travel the length of the shoebox, and if they can withstand wind. My kiddos at home, y'all need to do this. You can do it today or you can do it tomorrow. You're going to state the problem in your own words. I already told you what the problem was.
Wait.
Design a boat that holds 30 pennies, travels the length of the shoebox, and can stand up in wind and waves. How can you use the results from part 1? That's this part right here. How can we use these results to help you design and construct your boat? Now it says clay, but we're actually using tinfoil. Brainstorm a design and design a solution to the problem. Sketch or describe some possible solutions in the space below. So you're going to draw and label. Don't just draw it, but label your design right here. After you have finished page 39, you will go to page 40 where you will actually test it. You will test it in normal conditions. That's without the wind and waves. You will say the maximum number of pennies it held, the number of seconds it stayed afloat, and the distance it traveled, if it traveled all the way across the thing or not. You get to try it 2 times. So your first time, you can redesign it and try it again to see if you can make it hold more pennies or stay afloat longer. Then you can test it in windy conditions. That's when you put the ruler in there and you make waves to make it stay up. So you'll test it with the windy conditions, see how many pennies it can hold in windy conditions, winds and waves, how many seconds it can stay afloat, and the distance it'll travel with wind and waves. And you'll get to try that 2 times. Now, between your first and your second attempt, you can get new pieces of tinfoil to make a new design. All right? So you should have 1 piece here, 1 piece here. Remember, they're only 12 by 12 inches each. Please, when you are testing your boats, if you can videotape yourself and send it to me, that would be most helpful. I'm gonna videotape these lovely monkeys who are very eager to design their boats, and I will send you their designs, because on not page 41, on page 42, which you probably won't do till Thursday or Friday, that's when you say if your solution's the best, what could you have done differently? Well, you're gonna use ideas that other people had. Hopefully, if I get other videos, you'll be able to watch those and answer those questions. So, just to review, this page should be completely filled out today. You can fill this page out today if you want to, or you can wait until tomorrow. You can work on page 40 and 41 on Tuesday and Wednesday. By Wednesday, both of these pages need to be finished. You need to have your boat designed and tested and redesigned. Make sure that you answer the questions that go along with it. Don't just do all the fun part. Do y'all have any questions for me? Benjamin?
Yes.
What's your question?
My boat's not gonna work.
That's not a question. You'll be surprised. Elise, do you have any questions for me?
Yes.
Okay.
Are you gonna help us when we do this stuff?
Nope, you get to design your own boat.
Okay.
All right. Tell the kids at home, say good luck.